In our next example, we're told that producers will make 2,000 refrigerators available when the unit price is $330. And then we're also told at a unit price of $450 that 1,000 refrigerators will be made available. So we are supposed to write the unit price P as a function of the quantity variable X, i.e., how many are available, how many are in supply. Then once we have that, we'll find out how many refrigerators will be marketed when the unit price is $390. That's somewhere in between 330 and 450. So we should expect our answer to be somewhere between 2,000 and 10,000. So let's see what happens. So once again, I'm going to calculate the slope. We have price dependent on the number of refrigerators in supply. So price is standing in for Y. The $450 is paired up with 10,000 refrigerators, while the $330 is paired up with the 2,000. Check my calculations here. I'm coming up with 3/200. Now that, by the way, would be a nice decimal, but not all examples will be. So you may not want to divide and then come up with a decimal, because that could lead to some rounding and could lead to round off error later. So let's see here. Let me show something else along those lines, just a moment. We had for the slope, before I reduced 120 over 8,000, what I did was I divided top and bottom by 40. We're going to see this as a nice decimal, but if a decimal is not wanted on a TI-84, you can press math, and the very first option will convert that decimal back to a fraction. Every once in a while, there may be a series of many steps that led to that decimal that won't allow it to convert back to a fraction. But in this case, there it is, 3/200. So going back to the PowerPoint here, let's see. All right, try again. There we go. All right. So with a slope of 3/200, what I have shown next is solving for B. Neither one of those points had an X coordinate of 0. So since we are asked to write the unit price as a function of the quantity variable X, again, P instead of Y, and since we want that as a function of X, P of X instead of just P. If I plug in one of the points, it doesn't matter which. I took the first one where X, the quantity available was 2,000, and I'd sell that for a unit price of $330. I plugged that in along with the slope, and I'm going to solve for B. Now, would it matter if you would put 10,000 here on the left and 450 as what's being multiplied by 3/200 and then adding B? Okay, so I subtract the 3/200 times 2,000. I figure out that that is 30. Take that away from the 330, and we get that the y-coordinate of our y-intercept is 300. So plugging that in, there is our function where the unit price is dependent on the quantity available, x. Here's another option using the slope-intercept formula. And again, it wouldn't matter which of the 2 points that I started with. So this time I'll start with the unit price of 450. Going along with the 10,000 refrigerators as what will be available. So let's take a look at that. So distributing, all right, let's see here. Cancel 2 of the zeros there, along with 2 of the zeros there. And then 2 into 100 would be 50. 3 times 50 is 150. Add 450 to both sides. 450 plus a negative 150 would be 300. Positive. And then I would replace y with p of x. So let's see if that's the same thing that I had typed up. P of x equals 3/200 times x plus 300. See if that's the same. That is the same. And so if we're asked how many refrigerators will be marketed when the unit price is 390, I want you to notice that's going to go in here on the left. And we're doing algebra to solve for x. This is not arithmetic. We're not plugging in 390 for x. X is the quantity available. The dollars, that's the unit price. So I'm going to subtract 300 from 390 to get 90. Dividing both sides by 3/200 would be the same as multiplying by the reciprocal, as some people like to say, copy dot flip. So 90 times 200/3. 90/3 would reduce to 30. 30 times 200 would give us 6,000. And note that I have labeled what that 6,000 stands for. Those units, 6,000 units, that's 6,000 refrigerators. So on to our next one.